Okay, so this is going to be our third video for day 12, and in it we are going to discuss Descartes' rule. And if I'm not mistaken, Descartes, I think his name was Rene Descartes, he's the guy that said, I think, therefore I am. I probably have that jacked up, but anyway, Descartes came up with a rule applicable to algebra and finding roots for polynomials, assuming that they're standard form polynomials, right? So if you need to take a minute to pause this screen and look at what all's written here, feel free to do so. I'm going to go ahead and move on just for the sake of brevity. So this example, we're looking at this function g of x, and we're being asked to use Descartes' rule and find the number of positive or negative roots. Okay, so to do that, well, first we're going to begin with just regular g of x, and we're going to take note of the number of sign changes. So no sign change, positive, oh, we have one sign change. Okay, so this means that 1 or 0 of our roots are positive. Okay, now we're going to look at g of negative x. G of negative x, so 2x to the negative 3, or sorry, I said that goofy. So remember what we mean by g of negative x. Okay, so that means every instance of x is going to get replaced not with just x, but with negative x. So for example, we would have 2 times negative x to the third plus 7 times negative x squared plus 2 times negative x, and then the 3 is unaffected. That's still going to just be negative 3. So this right here, well, remember, cubes are inherently odd. So negative x to the third, that's going to become negative 2x to the third when we multiply that all out, okay? Here, well, this is inherently even because it's a square. So that's just going to stay positive 7x squared. And then 2 times negative x, of course, that becomes negative 2x minus 3. Okay, so g of negative x is negative 2x to the third plus 7x squared minus 2x minus 3. Okay, and we're looking at the sign changes of this, right? So we're looking at the second note. The number of negative roots is going to come from when we look at the sign changes relative to g of negative x. So we start negative, oh, then we're positive. So we have one sign change. Okay, so one sign change. Then we have another sign change, and that's it. So 2 or 0 of these roots will be negative. Okay, and they have to add up to 3, right? This is a third degree polynomial, so that means 1 is positive and 2 are negative. Okay, very simple. All right, so let's look at another example. Now, this example is using our same f of x from the previous video. So this is the exact same f of x that we used in the previous video here. Okay, so same idea. We need to know how many sign changes there are relative to f of x and how many there are relative to f of negative x. So sign changes relative to f of x. So we start positive, oh, sign change. Still negative, and sign change again. So then this means 2 or 0 of the roots are going to be positive. Okay, so now let's calculate f of negative x. Well, this is going to be negative x to the third now. That negative 2x squared is going to stay just how it is. This is going to become positive 5x and then plus 6. Okay, so let's look at sign changes. So we start negative, stay negative, oh, change to positive, and there we have it. So one sign change. So that means 1 or 0 are negative. Or 2 are going to be positive because they have to add up to 3. It's third degree, right? So 2 are going to be positive, and 1 is going to be negative. That's the only way that we get 3 total. Okay? So there you have it. That's how you use Descartes' rule. That's going to do it for this video. If you have any questions about Descartes' rule, be sure and send me an email or come and see me. Goodbye.